Hi, thanks for watching this video. This is Mr. Bowman, and in this video we're going to talk about arithmetic series. Okay, so a series, by definition, is nothing more than just a sum. Sum means to add. It's nothing more than the sum of some of the terms of a sequence. That's what we call a series. Now, there's a shorthand we use for series in mathematics, and it's right here. It's what we call sigma notation. This letter that looks a little bit like an E is the capital letter sigma. And whenever in science or mathematics you see the capital letter sigma, you generally want to think that that indicates a sum of something. What this notation means here is it says take the sum of all of the terms of this sequence, whatever this sequence a sub n is, starting with the first term in this case, and ending with whatever this term is. So essentially, you could think of this as this number tells you where to start, like start with this term. We call this variable the index, by the way. That's why we use I there. From the first term to whatever this term is. So if I wanted to find the sum of this sequence from term number 1 to term number n, that's just this. That's just term number 1 plus term number 2. Skip them all the way down until you get to the last one, term n. So for the partial sum of an arithmetic series, and the reason that that has to be a partial sum is that for an arithmetic series, you really couldn't add up all of the terms in an arithmetic sequence. There are infinitely many terms in that sequence. And if you try to add them all up, it just simply wouldn't happen. What we can do is we can find partial sums, sums of some of the terms in that sequence. And a shortcut rule is right here at the bottom of the screen. If we were going to be together at the end of this school year, we would dive way more into this than we'll get to now. But a rule for the sum of the first n terms of an arithmetic series, sometimes we also call it the nth partial sum, is right here. This S generally just stands for sum. The sum of the first this many terms equals n over 2, n being the number of terms you've got, times the sum of the first term and the last term. Let's practice with an example. Suppose we wanted to find the sum of the terms of this arithmetic sequence, 3n minus 1. We wanted to find the sum of all the terms from the first term to the 10th term. I need to know three things to use this formula. I need to know how many terms there are, n. Well, if I start at the first term and I end at the 10th term, there are 10. I need to know what the first term is, what a sub 1 would be. You know, if this is my rule for a sub n, what would a sub 1, the first term, be? Well, if I let n be 1, I get 3 times 1 minus 1, which is 3 minus 1, 2. And the last thing I need to know is what's the last term? What's the nth term? And if n is 10, I need a sub 10. And I can find that the same way I found a sub 1, just replace n with 10 this time. What's the 10th term in this arithmetic sequence? Well, 3 times 10 is 30, and 30 minus 1 is 29. So I've got the three things I need to use this formula now. The sum of the first 10 terms is 10 over 2, 10 is n, times a sub 1 was 2, plus a sub n, that 10th term is 29. So 10 divided by 2 is 5, and 2 plus 29 is 31. 31 times 5. How about 155? If you wanted to check that, you could find all of those terms from 1 to 10 and plug them into a calculator. And what you'll see is that is indeed the sum. Thanks for watching.